Good afternoon, everyone. My name is Andrea Vecchi. I'm a research fellow at the Department of Mechanical Engineering here at the University of Melbourne. Today, I will be moderating this seminar. So before we begin, I'd like to acknowledge that we are gathered on the lands of the Wurundjeri, Woi Wurrung, and Bon Wurrung people, which have been the custodians of this land for thousands of years, and we acknowledge and pay our respects to their elders, past and present. So I'd like to thank people joining in the room, as well as people joining the webinar online. For those who are joining online, a bit of housekeeping, so feel free to put any questions you may have in the Q&A box, as the chat function will be disabled. And then we will go through the presentation, and at the end, we will have time to ask our speaker questions. This is the fifth of a series of webinar and seminars that the Melbourne Energy Institute is providing this year with the theme Electricity Supply Chain. Obviously, previous ones are accessible through the Melbourne Energy Institute website. So let me now introduce our speaker of today, Cameron Owens, Head of DER and Engineering at Synergy, which is an electricity retailer in Western Australia. Cameron holds a bachelor degree in electrical engineering and an MBA from the University of Manchester. He's been 12 years working in the energy sector. He leads a team focused on renewables, DER, and storage. And he has driven his company's strategic initiative to secure the first virtual power plant for market services in Western Australia. So I would say, without further ado, I would let Cameron speak, and he will tell us about the electricity market in Western Australia. Thanks, Cameron.
Thank you.
Yeah, this.
Yeah, just before I start, I'd also like to acknowledge where I'm from, which is Boorloo, Perth, Whadjuk land. Acknowledge the First Nations people and their ongoing connection, and how lucky I am to share that connection now with the lands. If anyone hasn't been to WA, beautiful state, highly recommend checking it out. All right, before I dive into the presentation, just a quick disclaimer. And I've got this photo here, because I really like this photo. It's of our Kwinana storage facility. So in the foreground, you've got Kwinana Battery Storage 2 project we're currently building. In the background, you've got a couple of large stacks. That's our old Kwinana coal-fired power station. And you've also got some gas turbines there. So it really is a good mix of the old and the new. The coal's currently going through demolition. This battery here is due to be commissioned this year. And I've been lucky enough to work across coal, gas, renewables, storage in my career, but I know enough to know that there's a lot more that I don't know than I do know. So what I'll be giving you today is a bit of my experience, a bit of external and internal reference points, but by no means take it as gospel. I'm here in the spirit of, I guess, sharing some of my learnings and observations of the industry in the West. So just quickly a bit about Synergy, who we are, what we do in WA. So our vision is leading West Australians to their intelligent energy future. We're a Gen K line, so we've got the generation arm, and in the map there on the left-hand side or right-hand side, you can see we've got a number of coal, gas, wind, solar, and increasingly a lot of storage facilities that we operate, maintain, and asset manage. On our retail arm, we've got around 1.1 million customers. Importantly, in WA, we're a regulated monopoly for the residential customers. So the mums and dads, they come to us for electricity. There isn't contestability like you have over here on the East Coast. And I'll touch on that a bit later in the presentation, as it's quite an important part. And you can see the network that we operate is the Swiss, that kind of dark yellow area, which stretches from up north Kalbarri, down to Albany, and out to Kalgoorlie. So I'm breaking this down into two parts. So I'll run through both parts and then take questions at the end. The first one's really just an introduction to electricity systems, markets, and how they're implemented on the West Coast. And then the second part is really looking at some of the changes and challenges we're observing on the West Coast now.
Sorry, we're having some issues in the with the slides, so I'll just try sharing those again.
While you're doing that, it's one final thing to add to the disclaimer. I do have a very low mumbly voice. I am speaking English. It's not because I'm West Australian, so just bear with me if you can't quite understand.
Is that where you were? Sorry.
Yeah, just on this electricity system one. Without the presentation, you know.
We're having some problems. Sorry about that. Just bear with me a moment, folks. Sorry. Just share those in. Been very promising, is it?
Yeah, it's okay.
Okay. Thank you.
All right, so basically the electricity system, very general, simplified view. Central generation was the traditional mix. On the West Coast, this was primarily coal, gas. I had black coal down in the Collie region, and a few gas plants for Fermi. We've seen a lot of wind and solar coming onto the system, and increasingly storage. That was bulk transmitted through the transmission network down to load centres, and then distributed through the network to the distribution network for the end use consumer. So again, system quite basic view, should be too new to most people. Our system is called the Southwest Link Connected System, or the SWIS. And what's unique about the SWIS is, I guess, just how big it is geographically, but how sparsely populated it is. So when I refer to West Coast and the electricity system in the WEM, I'm referring just to the southwest corner. So there is other networks in the north of the state, which are operated by Horizon and other private mining companies. But I'm specifically referring to the SWIS. So keynote there is we're about the same size geographically as the UK, but we're serving 2 million customers and they're serving 67 million. And what that translates to is that note down the bottom, 50% of the assets that are fixed, like the transmission distribution network, is to serve 3% of the customers. So it presents quite a unique challenge in how to do that efficiently. You've got, like most Australian cities, very high concentration of people living on the coast. So from Perth to Bunbury, that 200-kilometre stretch, you've got roughly 90% of the population living in that load centre. And just east of Bunbury, it's not shown in the map there, is Collie, which is basically a coal centre and traditionally where the large generation sources were. In terms of the size of the SWIS, so some of our records, we've got around 4.2 gigawatt. So again, very small relative to the NEM. And the minimum demand increasingly going lower. So we hit about just under 600 megawatts last spring. And we've been up to 84% renewable penetration. We've had the ability to go to 100% in terms of having available resource, but haven't had the, I guess, operational confidence to actually go there. Now, in terms of the fundamentals of the electricity system and what we need to operate, I like this simple overview from AMO, which talks around what are the different physical things you need to operate a power system and over what time horizon do they operate. So the first one really is around resource adequacy. So you need to make sure you've got enough supply to meet your demand. And this is both from having strategic reserves like high-speed, high-efficiency gas turbines that can ramp up and down quickly, but also having strategic reserves. So traditionally we had coal stockpiles down at Collie, which could provide energy over days and weeks and months. You also need to manage the frequency, so making sure that Frequency is used as an indicator of that supply-demand balance, and that happens from milliseconds right out to seconds and minutes. So again, in our system, we have the inertial response primarily provided by those synchronous spinning machines, the large coal-fired units, and some of the co-generation gas turbines. And then we have primary and secondary control, which some of it was mandated, some of it is market-based as well. You also have to manage the voltage to keep within the limits and comply with those physical constraints. When things go wrong as well, you need system restoration services. So this is an incident we had over summer where we had the line out to Kalgoorlie in the east, went down. So we needed to isolate that part of the grid and start it with our black start services. So we've got a couple of gas turbines out there that provide that service. Again, it's one of those things that you have to plan for, but you hope doesn't happen. So that's, I guess, the easy bit of the electricity system in my mind. I guess as engineers, if you had unlimited resources, you can solve for that relatively easily. The challenge is how do you do that efficiently? And that's where markets come in, trying to convert those physical needs of the system into price signals for the market. So it's really around how do you do it economically efficiently while balancing the security constraints of the system. And increasingly now you've got the third leg of that energy trilemma, which is around sustainability. And there's been various attempts to try and convert that into a market signal. Carbon tax, capacity investment scheme now is the latest one to try and figure out how do you balance this dilemma. And the other key concept, market concept of supply and WEM certainly is really the principle of cause and pay. So if you're the user of the electricity, you need to pay for the supply. Likewise, if you're a consumer or a causer of one of those services, such as voltage or frequency issues, you need to pay for that service to keep the power system stable. Now I'm just going to quickly look at, I guess, the WEM versus an M. There's a lot of different aspects on here, but the two critical ones that I want to point out are really around, firstly, the size. So, as I mentioned earlier, it's about 10x difference between the NEM and the WEM in terms of energy and capacity. And there's some other differences in market design. The critical one is really in the cost recovery mechanism. So in the WEM, we've got what's called a capacity market, and we've got a mechanism called the reserve capacity mechanism. So unlike the NEM, you see the energy prices are a lot higher because the generators are recovering their short run and long run marginal costs. Whereas in the WEM, the generators can recover their long run marginal costs or the fixed components via the reserve capacity mechanism. That's a critical difference between the WEM and the NEM and how we've implemented those markets to manage the power system. So I'm going to very briefly summarise some of those key mechanisms now in as simple terms as I can in terms of how that cause and pay principle is implemented. So obviously there's the physical bulk transmission and distribution of the power from generator to customer. So the consumer is generally paying for that transport infrastructure to be in place and for the energy they consume. We then got the reserve capacity mechanism. So this is designed to ensure there's sufficient capacity to meet peak demand. So the market operator will forecast 2 years, 3 years out and forecast peak demand, and then it will go and procure capacity from the market. And that'll be set at a price which is paid at availability. So they need to be available to provide on peak, not linked to energy. And likewise, on the flip side, the consumer is the causer of that peak service. So there's a mechanism to look back then in retrospect when the year passes. So over the last summer, they'll look at what consumers contributed the most to peak and they'll be allocated the costs. There's a real-time market when generators can sell. It's a security constrained economic dispatch. So generators submit their bids and offers. The network operator will run their constraint model and feed into that, and it'll be a secure constrained economic dispatch. And consumers can buy that energy. Most of the energy is actually transacted through bilateral contracts, which is effectively two different counterparties directly contracting for energy. And then the final one is the essential system services. So we went through a market reform process over the last couple of years, and this was changed. It used to be renamed ancillary system services, and somewhat similar. I think you got the FCAS on the NEM. And they changed it deliberately to essential system service to recognise the growing importance of those services for the stable operation of the power system. So again, the generators can provide those ESS services, and the consumers that need the ESS or cause the need for the service contribute to paying for that service. And where retailers fit in, obviously most mum and dads aren't going on the energy market, doing deals with generators, paying for ESS. The retailers effectively bundle all that up and provide a direct price signal to the consumer. So that's where we sit. We own generators, but we also sit in that retail arm as well. In terms of cost of the system, so again, these are rough numbers. Effectively, the energy capacity, so the generation component, the transmission and distribution, somewhat similar. The retail costs about 10%, and other regulatory and environmental charges about 10%. And importantly, these are made up of fixed costs, so the transmission and distribution and the generation assets, the capital involved to build those, regardless of how often they're used, is a big driver of those costs. And then traditionally there was the variable costs, and in our market, that's the recovery mechanism through the short-run marginal cost or the energy market. And that was typically the fuel inputs, which was coal, distillate or gas. Now the wind and sun, no fuel costs, very lucky. But then you've also got the operations and maintenance costs. So especially the old plant that had wear components, the more you use it, the more maintenance costs. And these are roughly translate to how the generators would reflect their bids in the market. So in an ideal market, the generator should be bidding at their short run marginal costs, which is basically their variable cost to operate. So how does this flow through to build on the West Coast? So on the West Coast, as I mentioned, we're the regulated monopoly retailer to mum and dad's residential customers, and we've got the A1 tariff, and that's the unregulated tariff. It's made up of two key components. There's a supply charge, which is roughly $1 a day, comes out about $400 a year. And then you've got electricity variable charge of about 30 cents per unit. And the average bill is around $1,500 to $2,000. So this tariff has been quite good and quite a good signal to customers in the traditional system around the cost of the system. But as we transition, it's starting to, I guess, have some challenges. So what signal is this sending to the customer? This is saying supply and fixed costs are not really the main driver of the bill. So you get $400 fixed cost, but most of it is variable. Energy costs the same any time of day. So whether you're consuming at 6 p.m. or 6 a.m. or midday, this tariff doesn't discriminate. It's all the same. So the best way to save money is use less energy. Or what we saw or have seen in the West Coast is increasingly a huge amount of solar PV going into the West. So we do have a number of other products, and we've got some time of use products and some hardship products, but most customers still reside on the A1 tariff in the West Coast. All right, so that was a bit around the system today, I guess, and how the WEM and the Swiss has been operating. This next section I'm going to go through is more around what we're seeing changes with the energy transition and some of the challenges and opportunities that's presenting on our market. So we'll go back to the electricity system. Some of the changes we're seeing is the disappearance of coal. So as I mentioned, we own some coal generators. We've retired one, got another one coming up after summer. And the last of our synergy-owned coal generators will retire by 2029. And there won't be any more synergy-owned coal assets in the Swiss. Seeing huge increases in solar, wind and storage to try and replace that coal generation and get ready for the retirement of those. And then we've obviously seen the widespread uptake of DER on the distribution and really a truly two-way power system now happening. And primarily solar PV. We haven't seen as much residential batteries as the East Coast has. EVs are starting to take up. And also there's a few assets starting to connect to the distribution network. Really, we are starting to see that two-way power flow across the system. So really changing how we need to think about our role as a generator and a retailer now where we've got generation assets at the other end of the pipe. What does this look like on the supply side? So this snap from OpenM back in 2007, this is energy throughput for the year or generated. We're about 6% renewables back in 2007. That was primarily coal, so again, large coal-fired assets in the southwest near Collie. Gas was the other leading supply, and we had a little bit of wind operating in the Swiss back then. If I look at 2023, so last year, we're up at 35% renewable energy generated. You can see the mix there. Coal obviously starting to retire, starting to get pushed out by increasing solar generation. Wind has increased a bit and gas has reduced less so. So yeah, we've gone up just under 20% in 30% in 17 years. Not bad, not great either. It's not really going to get us to where we need to go at that pace. If we look forward at one of the pieces of work that looked at the demand assessment for the Swiss and what it could look like, I guess, over the next 10 to 20 years, it paints a pretty interesting picture on how much capacity would be needed to meet some of these ambitious decarbonisation targets. So if you look at, might be hard to read, but you can see 2023, 24, our capacity is around that 5-6 gigawatts. And you can see at 2030, we're up 12 gigawatts, so doubling the capacity in 6 years. Pretty ambitious to meet, and then it steps up even further. Again, this is some modelling, lots of uncertainty with the pace of electrification, primarily industrial loads. Is hydrogen going to take off? Those kind of things, but it just really paints the picture of the pace today has been quite moderate, and it's been the easy bits, the easy abatement. So the grid could really handle this kind of mix quite easy, can absorb. The next bit's a lot more challenging. So on the demand side, WA has a love affair with solar, rooftop solar, and again, that A1 tariff has been a good price signal for that. So 2023, we're at about nearly 40% of households having solar, and again, that's predicted to still keep growing at a rate of knots. And what that's turned into is really this duck curve and this decaying minimum demand. So the graph has got 2 arrows on it, and that's because almost each season we need to update it with the new record. So yeah, last September we hit 595. Thankfully, the security limit shown there, AEMO have managed to keep moving that down. So they're doing a lot of work to figure out how can they run the system at lower demand levels. And the other thing you notice is the peak getting higher. So huge ramps to counteract the solar turning off or as the sun goes down. In terms of electric vehicles, 2023, 13,000. I think we're at about 20,000 now. And by 2030, again, the amount of energy demand on the network is expected to increase significantly. A lot of uncertainty in the numbers and the timing and the consumer preferences for charging, which can have a huge impact on the peak demand and the solar curve as well. And as I mentioned before, behind the meter battery capacity in WA, a little bit lower than on the NEM, but still forecast to grow, maybe just a bit more delayed. So there's some challenges here on the demand side as well. So what's this led to? It's really a bit of a perfect storm on the West Coast with such a small network. So seeing very large load swings from DPV, so sometimes up to 300, 400, 500, 600 megawatts between half-an-hour intervals with cloud cover. This is pushing the level of minimum demand very low. That squeezes out the synchronous dispatchable generators, which in turn lowers the level of inertia. Then on the supply side, as I mentioned, you've got renewable generation, very volatile as well. These challenges are then, the power system challenges are turning into market outcomes as well, having impacts on revenue certainty. We're starting to get to that point where the non-synchronous renewable generation will exceed synchronous generation. And then this is feeding into stronger than expected growth for solar. We're kind of on this loop of this spiral down. So we look at that's the power system side, we look at the transmission side. As I mentioned before, the main transmission traditionally was between Collie and Perth. So again, when the system was designed, you build your transmission system to your fuel source, and Collie was where all the coal was. So you build the bulk transmission from your generator to your load center, which was the Perth metro area. So the coal's starting to go. There's been a lot of battery resource going into that region just to make use of the existing transmission infrastructure. The wind resource, so I guess the new fuel, is primarily in the north, east, and the south of the state. There's quite good wind resource through that area. And solar resource is pretty consistent, not a lot of diversity in solar across the southwest. It's all pretty good, pretty sunny, so customers have been still uptaking solar. I guess the key challenge is when they built the coal plants, they built the transmission system, it was socialised, and now the batteries can benefit from that existing asset. With the wind resources, Geraldton, Kalgoorlie and Albany, very small rural towns, not a lot of load on them. So that's very skinny, constrained network areas. So there's a real challenge in terms of getting the new fuel supply to the load centre. And that's one of the other challenges we're dealing with on the Swiss. Now, I'm just going to walk through, I guess, a couple of real examples now we're seeing over the last summer as well, some of the challenges that's created. So this is from this summer that's just went. It was a very hot, dry summer in the west. We had our last peak demand record in 2016. So it had been 7 years between records and peak demand. It hadn't really eclipsed that 2016 peak. And then what we saw in one summer was we beat the record 8 times in one summer. Again, just highlighting that challenge of like how AEMO and the power system plan for these events, and how do you ensure you've got sufficient capacity, which might just be a 1 in 10 year event, but consumers do expect to have reliable energy in those events. So what did it look like in terms of renewables and solar contributing? Yeah, it was very extreme weather, very unusual. We had some peaks on a Sunday, which is very atypical for the Swiss and the WEM. We had consecutive very hot days. The underlying demand, you can see in the middle there, hit 5 gigawatts. So this is with the solar PV contribution as well. So solar is playing a critical role in reducing that peak from 5 gigawatts to 4.1. So it would have been a lot worse if we didn't have the DPV there. AEMO really utilised all the levers they had. So every generator was being dispatched regardless of merit. Synergy was involved. We were sending text messages to customers saying, "Can you help us out if you didn't use less energy?" It was quite a nerve-wracking scenario for AEMO and the power system. The underlying demand, like I mentioned, 5 gigawatts, but all 3 days, basically the loss of a single large generator could have resulted in some customer load shedding. So cutting it pretty fine. You can see that a little bit of purple popping up down the bottom. Might be hard to see. That's some of the energy storage resources just starting to make a little dent on the mix. So we zoomed into one particular day. So this was the 8th of February. And again, this just presents the immense challenge we have with the decarbonisation shift. So key here is, if you're looking at the table there at 555, the fuel mix. So that middle column, the fuel mix, you had 60% gas and 30% coal. So at the peak, there was 90% was still coming from fossil. Even though we got 35% coming from renewables on average on energy, the peak capacity, the wind and solar wasn't sufficient to cover it. So again, this is a 1 in 7 year event maybe. You're going to need to have enough peak capacity available to meet demand on days like these. One of the other issues we're dealing with is, I guess, that volatility on the generation side. So this was some forecast versus actual for one of those hot days as well. It's becoming increasingly important because, again, the size of our system is relatively small, so like load swings can be quite material. This forecast, I looked at I guess you look at the graph on the right, the forecast was up at just over a gigawatt, solar PV then coming down. And what actually played out was about a 700 megawatt delta between the actual and forecast. So again, that was a shortfall of around 3.5 of our coal units, which AEMO had to manage through a combination of fast start gas turbines and battery storage. Again, you can just see the sharpness of some of these swings, and again, very material for a relatively small power system. So storage. this seems to be the answer that we've been looking to in the West. Ideally, we want long duration storage to help us be able to ride through some of these events. Unfortunately, again, if you haven't been to WA, it's very, very flat. It's not blessed with big mountains and nice big hills and reservoirs. So we don't have some of the hydro resources like Tassie and New South Wales do. So we have looked into that, but to date haven't really been able to find a suitable solution. So what's been invested in instead has been, I guess, a lot of lithium ion and quite a significant amount. So there's private players from Alinta investing in a couple of batteries, Neowen as well, building some large batteries down in Collie, as well as the ones I mentioned. So we're building a couple in Kwinana and at Collie, and there have been a few community batteries and behind the meter batteries also. So these batteries have been, I guess, incentivized by that reserve capacity mechanism. So a lot of those fixed costs in standing up the assets is procured through the reserve capacity mechanism, or AEMO has been using what they call the NCAS, which is non-co-optimized essential system service, which effectively is a Swiss Army knife toolkit that they can draft the service spec and go to market for services to help them bridge this energy transition where there is so much change happening very rapidly. So that's what the Swiss looks like at the moment, but even with all that storage, so we've got about, I think it's close to 2 gigawatts going in over the next couple of years. So very material for the size of the WEM. Us alone, we're putting in around 800 megawatts in the next, we've got 200 megawatts 4-hour battery coming on this end of this year, and then another 500 megawatt 2 gigawatt hour battery coming on at the end of next year. But it isn't enough still to get through what the Germans refer to as Dunkelflaut. I don't know if I'm pronouncing that right, but it means dark lull. So we've been doing some research into what we've been calling renewable droughts, and looking at when are those periods where there is low solar and low wind output, and they are coincident, and how much storage would you need to get through those kind of scenarios. So if we look around the Swiss, what I'm showing here is a chart with the vertical axis is the number of days of the drought, and on the x-axis is the capacity factor, and each bar is a different year. So we went back and looked at some satellite data, some other local measurement data, and looked at when do we have periods of low solar and low wind. It will show each by its own technology. So when was low wind, what year, when was low solar. The key one to focus on here is really the combined output. So 2014 was a relatively bad year where we had about 2 weeks of a capacity factor of 16% combined, which is about half the average capacity factor for the Swiss. And you can see that year it had 13, 12, 11, 10-day record as well. And then down the very bottom, you have 1-day instances where you've got as low as 12% capacity factor for a day. So really raised the question of how much extra energy would you need to have enough energy to fill up that storage and actually redeploy it every evening and cover the peak. So again, what solutions are out there to cover these long duration droughts? So not sure at the moment. There's emerging technologies of long form duration like hydrogen and other long form storages. You can just double the capacity, build a lot more wind and solar resources, and for those 1 in 10, 20-year events, or you can, I guess, connect to the NEM. So again, lots of different options. There's something very early stages that AEMO and we're looking into in what does the future when Swiss state look like and how do we actually deal with these events? And critically coming back to who's going to pay for that, for those really low probability events. So this slide, I think, is a nice summary from ERA, which looks at some of those impacts and the causes. So as I mentioned, solar is really popping up on the generation volatility. So we're seeing those huge ramps with cloud cover. It's pushing down minimum demand and then it's pushing up the rate of change. We're really needing fast ramping services. Wind is pushing in the generation volatility, so again, contributing to that mix. And really to date, the dependency has been batteries. So battery storage is effectively lithium ions are able to deal with most of this stuff for those, I guess, day events. but not so much for the renewable energy droughts that we're dealing with as well. So I guess to summarize, what we need here is there's a lot of new energy required on the Swiss. There's a lot of new capacity as well. So importantly, there's the energy and the capacity that's needed. There's new services required as well. So again, going back to that power system fundamentals and how they're converted to markets, a lot of that needs to be revisited to figure out, okay, how do we adequately incentivize the right technology investment? So an example of this is that demand rate of change. The market operator and policymakers are currently looking at a new flexible capacity product, which is aimed at incentivizing investment in fast ramping generation technologies. And we need more storage. And there's still really a policy and social question with all of this transition is who's going to pay for this? Again, in the past, when we set up the systems and the markets, it was socialized. We're now in a more deregulated system. And what we're seeing, I guess, in the customer impacts is there's changes in the costs coming into the retailers, and different retailers have different abilities to pass on those costs to customers and through their contracts. And what we're very conscious of is ensuring we don't end up with I guess, a two-speed economy where you have some of the people that can afford and invested in DER, for example, and help drive, done the heavy lifting to date of the decarbonisation. We want to make sure we don't leave the other customers behind that maybe can't afford to invest in the capital for the DER, and they're at I guess, the mercy of the retailer that could pass on any increasing costs that may flow. There's a really interesting, I guess, social license policy question that needs to be resolved through this transition around how are we going to reallocate the cost of the system to the right parties in a fair and equitable manner. So that's been pretty downer, I think, pretty negative. Just want to have a little break, have a look at the nice view. This is one of our solar farms up at Geraldton. What I presented was obviously all the challenges, but it's actually never been more interesting or exciting to be in the energy industry, because we're basically at that inflection point now where we've got the pen and the ability to change the direction of the system and solve some of these issues. And again, if it was easy, then most of us wouldn't be as interested in it or be employed in the industry. So what are we doing about it? I guess at the moment, as I mentioned, we've got a couple of wind and solar farms in operations, and our first storage facility went into operation last year. So for us as a business, we went from not constructing any new facilities. The last one we built was in 2012, a high efficiency gas turbine, very steady state, operating coal and gas, very little movement through the teens, and then all of a sudden in the early 20s, we built one battery last year. We've got another 2 batteries coming online, one this year, one next year. We've got a number of wind farms in late stage development. And then in feasibility stage, we've got a lot more renewable and storage opportunities. I guess one of the key ones we did want to point out, one of the areas I work heavily in is the DER space. Still see there's a really big opportunity here to get DER even being more integrated with the system. At the moment, it's still probably got a perception that the WEM and the Swiss is a bit of a problem child and a cause of some of these issues. We really think there's a huge opportunity to get them better integrated into the system, which will help deliver a lower cost decarbonised system. And just to close, I like this view from a guy called Johan Strockham. If you've seen any of his stuff, he did the tipping point research. And this is one of his from his most recent one in 2024. And it really does, I'm certainly got a lot of optimism about where we're heading. At the 2020s, it's been a bit of a slow start, but we really are at this tipping point where you're starting to see a lot of political progress and momentum behind the transition. You're seeing a lot of the technology disruption, so lithium-ion prices starting to come down, consumers investing in electric vehicles, solar, and again, market forces. So the markets over in the WEM, the Swiss are now starting to send the right signals, and we're starting to see rapid uptake of these new technologies. So yeah, wanted to close on a positive note. I think we can see a clear pathway to decarboning and having a low carbon system by 2050. Thank you.
Okay, thanks, Cameron, very much for the presentation. I think it was interesting to see let's say, how the system is evolving and some of the challenges as well as opportunities that this is bringing along. I'll open now the floor to questions, whether there are some here in the room. Okay, I can see a few, so just one. Like that.
Yeah, thanks, Cameron. Really interesting. I guess one of the things I kept thinking about as you were talking is the role of the end user, consumer, prosumer. You know, if you think about the actual economics of what's been installed on rooftop households over the last 15 years, you know, 50%, if not more, of the cost has been borne by the individual. So in terms of funding the transition, individuals are on the path, and financing solutions sit behind that. I'm interested in the capacity issue and the electric vehicle and vehicle to grid technology, particularly because you hear a lot about people saying, "Oh, why would you use a car battery for anything other than motive force?" But if you think about how many cars are going to be on the road, out of what 2 million people, you probably have 500,000 cars on the road in 15 years.
Yeah,
that's a lot of capacity that's going to be sitting there, and if you're worried about, you know, serving up a dark winter, could be an interesting option. So interesting in your thoughts.
Yeah, that's a good question. We have been thinking about EVs quite a bit, and we're in kind of early phase, but yeah, the similar thinking to yourself in just the magnitude is quite impressive. So we've had, I mentioned 20,000 vehicles around WA, assuming about 50 kilowatt hours. You're talking a gigawatt hour capacity rolling around. Our latest forecast, we're looking at around, is in the tens of gigawatt hours in people's cars. So yeah, you don't have to get a lot of penetration to get a significant amount of storage. So yeah, I think vehicle to grid is it's in the background there. There's obviously some technology challenges and customer appetite, but yeah, I tend to be optimistic about it as well. There's a lot of things that if you ask people around, would you drive your own car as a taxi? A lot of people 20 years ago would have said, "No, you're crazy," right? There's a lot of things that people will do if the incentives are right, if the experience is right as well. It has to be seamless. You can't have customers not being able to charge the car or going to use it to be flat, but all of that stuff is, I think, to be solved over the next in this decade as well. And yeah, I see it as a really big opportunity. Yeah,
and economic efficient too. You know, kind of three things.
Yeah,
economic efficiency, security, and renewals. Yeah, thanks.
Cameron, great talk. So, I mean, of course, in the NEM, there's a lot of talk about very fast FCAS. I mean, that's really been the big technological advancement for batteries providing services and sort of paying themselves off. My question is, obviously that doesn't exist in the Swiss. You have a capacity mechanism instead, or something to that amount. I'm wondering how you see sort of DER, how that plays in it. Obviously, DER's participating in very fast FCAS now. So does the Swiss need FCAS markets? Is the capacity mechanism enough to incentivize DER?
Yeah, thanks for the question. So we have the essential system service, and within that is our frequency optimized service, similar to the FCAS. We don't have a very fast. We have a speed factor, which basically rewards technology that is quicker. So it's kind of similar. Traditionally, that's been provided by GTs, and now the large scale storage is providing that. Still haven't got the confidence to be providing the inertial response. There's obviously some work to do with AMO and grid forming inverters, and if they can sufficiently replace that spinning machine. In terms of DER's role in that, Project Symphony was our kind of trial project around DER integration. We tested some contingency responses from the DER there and got some, I guess, mixed results. The key thing for me is really around the standardization of integrations. At the moment, or previously, it's starting to get a bit of a mixed bag of every different OEM having different APIs and configurations and not really playing nicely. So there's a key thing around interoperability that needs to be solved. But yeah, I see immense potential value in DER. The inverter resources themselves are not too dissimilar when you go from small scale to large scale in terms of their capabilities. Again, it's really figuring out how do you get the right incentives to retailers or the customers to invest in that technology. So, and then also fixing the rules and regulations so they can appropriately provide the service. So in the West Coast, DER isn't really able to provide on-market ESS at the moment. That's really more the remit of the large-scale facilities. But work is ongoing with AMO and Energy Policy WA to continue to reform the market rules to allow more participation. Yeah, so it's definitely part of WA's got a DER roadmap, and that's part of the vision is to get DER doing more for the system.
We'll take one more from the floor and then I'll ask a couple from the online audience.
Cameron, thanks for your presentation. I'm Dr. Val, I'm an energy writer for 3 publications. I'm interested in your comment on DER integration into the system.
Yeah.
And I recall the Swiss requesting customers to keep their air conditioners running to allow for stability in the distribution grid, which from an electrical engineering point of view would mean with too much in-feed, or rather too little in-feed from your main generator system.
Yeah.
You've got your PLLs not knowing what to do, and basically you've got a problem.
Yeah.
And it seems to me that overall in Australia, we're doing an absolutely shocking job thinking through what distribution networks could be doing, being net generators in the system rather than confining them to work on grid envelopes.
Yeah. No, thank you for the question. Yeah, but very close to what we're working on at the moment. So it's been recognised in WA that I guess that minimum demand issue and putting issues with system stability, voltage control, other distribution network. Today, yeah, we've done, I guess, some agricultural methods like load increases. We've also got the emergency solar management mechanism, which is similar to, I think you've got the backstop mechanism in Victoria going live. It's in October of this year. So we can turn off solar if we need to. Again, that's not ideal and not where we want to be. So Synergy is actually doing a lot of work, working with AMO, Western Power, Energy Policy WA, to really fix the market framework and policy framework and regulations. So DER can participate, and you've got, I guess, a more smart DER integration. Like I mentioned, we've got away with more, I guess, passive DER in the past, where you can just chuck a solar system on, you can just spill into the grid whenever, and the system was fine. That's probably not going to cut it when we go into a completely decarbonised system. So yeah, we're actively working on solutions to that problem, and likewise, like Western Power and the state government are very, very keen to help resolve this and make sure that customers end up with a really good experience, and also they get rewarded for that investment they put into those assets as well.
Thank you.
Okay, thanks. So just following up on that, how would you comment on the possibility of virtual power plants to, let's say, not only solve the generation issues in the market, but also solve some of the network overload or other issues? And what can be, let's say, the market schemes that can be in place in order to facilitate that?
That's a very good question, and very timely as well. So we've got that NCAS framework I mentioned, that non-optimized essential system service. That tool is, AMO can use it to procure capacity and energy services, but the network operator can also use that process. So in the Swiss, Western Power are both the TNSP and the DNSP. There's only one, they control both. Monopoly, which is, again, it's got its advantages in terms of it's one stakeholder. Just last week, they submitted to the Energy Coordinator a Network Support Services NCAS. So they'll be looking to tender for a couple of megawatts to resolve some of those thermal constraints on the distribution network. And again, they're primarily looking for those BPP solutions to help address. So they very much recognise that a lower cost system is one where it has BPPs integrated into the mix. So yeah, we're just starting to see the conversion of that power system need into that price signal, which enables, I guess, investors to act with more confidence and provide those services.
Yeah, thank you. And anything on the electricity tariff side to relieve like some of the potentially network issues at the demand side? So beyond
yeah, so at the moment the pricing is there's the network support services with contracting for a service. Western Power is also in their latest tariff release has introduced a new like community energy tariffs, which is designed to target front of meter distribution battery storage, which has very low charge rates in the middle of the day to soak up the solar, and then very low discharge rates in evening peak. So that they've been working quite hard to try and send those signals. Likewise for EVs, they've been introducing a few new tariffs around trying to incentivize EV, like high-speed EV charging infrastructure. Again, recognise there's a challenge there in getting the network assets filled in with an asset which has a very high peak capacity, but pretty low utilisation. So yeah, there is some work happening at that level as well.
yeah, one more from the online audience. So talking about recovering the short-run marginal costs from the energy market.
Yeah.
If you could speak about what are the restrictions, if any, on bidding different players in there.
Yeah, so because we control the residential market and we've got deemed market power, there are pretty strict regulations around specifically synergy bidding behaviour. So we're regulated by the Economic Regulatory Authority, making sure that we are bidding in a way that's not trying to manipulate and abuse market power. So yeah, that's effectively our strategy, and we also base that energy price is really around that variable operation and maintenance costs. Some of the renewable fleets, you'll see we get negative pricing in the WEM, and that's due to start costs. So a coal-fired power station, for example, very expensive to start. So we will be happy to pay to generate. It means we don't have to shut it down and start it again, because that has a much more material cost to use some liquid fuels to get it going. So yeah, that's part of it.
Thanks. Any more questions here from the room? One over here.
Thanks, Cameron. Appreciate it. David Dawson from Energy Security, Energy Storage Industry. Just a quick one. You've got three north, east, and south thin transmission links.
Mm-hmm.
To what extent might synergy look at installing battery storage at the actual source for the end of those three thin links? So then try and increase the utilisation and capacity of those links without Western Power having to spend money on increasing capacity. To what extent we're looking at that, and to what extent are you incentivised to basically undermine what is a monopoly asset with a market asset? To what extent is that issue addressed in the way?
Yeah, that's a very, very good question. Very challenging question as well. So yeah, to date, our storage assets have, I guess, been in the easy wins location, using up the existing. So we've been trying to fit assets in the existing asset base of the transmission infrastructure. We have looked at the kind of co-location of generation and storage as well. And you're right, there is a challenge in trying to, I guess, the chicken and egg around, are you doing it to avoid the cost and you're going to see that benefit or not? So probably not really a real clear direct signal. There's still a lot of I guess discussions around who's going to pay for this expansion of the network. Yeah, so at the moment it can present as an opportunity, depending on your risk appetite, if you're willing to kind of bet and try and defer the capital investment, or it can present as a risk of, oh, if I put it there, I'm going to get constrained, and then it affects my business case. So it's a really hard problem, and we haven't solved it yet. So yeah, there's still a lot of discussions in that. The graph I presented from around the forecast load growth, we've got a whole system plan and a Swiss demand assessment. So Energy Policy WA is kind of in leading the task force effectively to try and figure out where are these generation corridors, how can you co-locate, and how much can you, I guess, defer the capital investment of that transmission to try and keep the costs as low as possible. But yeah, not a solved problem by any means.
Any more questions from the room?
Thank you, Cameron. Really just a question around the political risk. As you know, the Liberal National Party, they're very much into this nuclear energy, but none of the forecasting or roadmap actually indicating the possibility of that. So what's your view on that?
Yeah, nuclear at the moment is very challenging for the Swiss and the WEM, I think. You know, we're a pretty small system. So most of the, I guess, investment is focusing on just the renewable and storage at the moment. Yeah, in our plans, we don't have any plans for nuclear, certainly out 2030. We're still working through what 2050 looks like and how to get there. Is there nuclear in that? Is there what role does gas play? Yeah, at the moment, we're focused mainly on wind and battery storage for now. Yeah.
Okay, we have time for one last question.
Thank you. This one is probably a little bit of an early question, but we'll go with it anyway. In the NEM, the signals that the distribution and transmission system operators put into the price board or the cost board, we won't call it that, don't necessarily, are not necessarily passed through directly by the retailers to the end user. Therefore, the end user tariffs that are seen have nothing to do with incentivizing consumers to do anything except make profit for the retailers. In Western Australia, in the WEM, is that different? Are the actual network tariffs mandated to be pushed through to the consumers so they can actually see it on their bill?
No. So in the WEM, the Swiss, that A1 tariff we've got, that's regulated, so set by the state government and reviewed each year, and any changes that go through the state government. So yeah, one of the issues we've got is with the changing system is synergy, I guess, is how do we reflect that the cost we're seeing in terms of supply from transmission and generation to the customers to give them the right signal. So yeah, there isn't a straightforward pass through. Our cost stack and what our cost of supply look like can be very different from that A1 tariff. And yeah, that's a very challenging topic to take as well, especially it becomes very politicised around energy prices are quite a hot topic. So very hard for a government to get up and want to be really enthused about reforming those to send that price signal. I think there's also a question around, I guess, the appetite for consumers for time of use. And again, there's been lots of attempts at passing that through with mixed reactions to that. So I think there's still a fundamental piece of what do customers really want as a product as well, and making sure that you're balancing that system need with, I guess, the customer experience and their expectations as well.
Okay, so please join me again in thanking Cameron for his talk. I'll close this session now. Thank you again for attending. Just letting you know that obviously you can access this webinar as well as the previous one through the MEI website, and keep an eye on the upcoming seminar on DER, as well as the MEI symposium, which we're going to run at the end of November. Thank you.